Most of the useful work happening in the real world takes place in shared spaces like homes, warehouses, and factories where people, objects, and even other robots are constantly moving around. That means future robots can't just master isolated tasks. They need to understand what's happening around them, react in real time, and work together toward a common goal, just like people do every day. Back in February 2025, figures showed two robots working together to put away groceries using a single vision language action system. Now the company is pushing things even further. Two humanoid robots powered by Helix 02 were able to completely reset a bedroom in less than 2 minutes. They opened doors, hung clothes, stored headphones, closed a book, threw away trash, pushed a chair back under a desk, and even teamed up to make a bed together. What makes this especially impressive is that the robots aren't being guided by some central controller. There's no master system telling them exactly what to do and no hidden communication between them. Each robot only sees the room through its own cameras and figures out what the other robot is planning based purely on movement, similar to how two people naturally coordinate when carrying furniture or folding a blanket together. Figure says this is the first time a single learned neural network has handled collaborative multi-humanoid tasks directly from visual input all the way to physical actions. In simple terms, the robots are learning how to work together naturally instead of following rigid scripts. The range of skills shown here is pretty wild. The robots can open doors by recognizing the handle, pressing it down, pulling the door open, and adjusting their balance while moving through the doorway. They can push furniture like office chairs using full-body coordination instead of just arm strength. One robot even carried clothing across the room and carefully hung it on a narrow coat rack while dealing with fabric folding and shifting in its hands. Another task involved picking up headphones, rotating them mid-air, and placing them perfectly onto a stand. The robots also handled an open book by lifting it and closing the cover carefully, while dealing with shifting pages and changing weight distribution. One of the standout moments was the trash cleanup task. The robot grabbed a piece of trash, balanced on one leg, stepped on the trash can pedal with the other foot to open the lid, and dropped the trash inside without losing balance. That requires a serious combination of mobility, balance, and coordination, all happening at once. Then there's the bed-making sequence, which may actually be the hardest part of the demo. Both robots stood on opposite sides of the bed and worked together to spread and smooth out a comforter. Unlike rigid objects, blankets constantly change shape, wrinkle, fold, and slide around. The robots had to predict each other's movements while continuously adjusting their own actions in real time. That's what makes this kind of robotics so difficult. Two robots in the same room create a constantly changing environment, where every movement affects what the other robot sees and does next. Add a soft object like a comforter into the mix, and the complexity jumps even higher because there's no fixed shape or predictable position to rely on. The entire sequence also happened in just 2 minutes. During that time, the robots switched between walking, balancing, handling rigid objects, manipulating soft materials, and collaborating together without any visible pauses or scripted transitions. Under the hood, that means thousands of tiny decisions had to be made correctly, one after another, while both robots adapted to a fast-changing environment. Figure believes this is an important glimpse into the future of humanoid robotics. Instead of building separate systems for every individual task, Helix uses one learning-based system that keeps improving as more data is added. The same technology that previously learned logistics work, laundry folding, kitchen cleanup, and living room organization is now capable of coordinated bedroom cleanup between two humanoids. This kind of progress suggests we're getting closer to robots that can actually function in real human environments, instead of carefully controlled lab settings. And seeing two humanoids naturally coordinate like this makes the future of home and workplace robotics feel a lot more real.